We were here in the last video. Let's move on to example 2. Now it says that there is a game called Mega Job, and there's a vehicle carrying passenger by an electric motor and steel ropes. And let's see. Now, part A, draw on figure 4 the free body diagram of the passenger. Okay, let's capture the passenger. So for this passenger, okay, this the free body diagram. So one is the weight, and the so there are two forces acting on the passenger. One is its weight, and the other force is the normal reaction by the vehicle. There are only two forces. Maybe I can name it. Okay, name it one as W, the other as R, right? So W is mg, and R is the normal reaction. So this is part A of the question. So this is the free body diagram. So part A. Now in part B, we are required to compare the magnitude of the forces you have drawn in A in the following stages. Okay, let's look at it one by one. So part, so this is B1. When the vehicle is lifted up at uniform speed, so net force is 0. Hence we have R equals to W. And then in part 2, when the vehicle remains at rest, the same reasoning. The net force is 0. And the third part, when the vehicle is released and forced under gravity. So A is maybe acceleration. Acceleration is downward. Acceleration is downward. So net force must be downward. Hence, weight is greater than the reaction R. And then we have part 4, which states that when the vehicle decelerates downward, so acceleration is upward. So net force must be upward. Hence we have R greater than W. So that wraps up part B. So part C. If a figure cushion is a student carrying a motion sensor on mega job discovered that while the vehicle is falling, the acceleration recorded is actually smaller than 10 meters per second squared. So 1. So this should it be part C? So C1 explains this in terms of the forces you have drawn in A. So should R equals 0, A take down with positive. Should R equal to 0, mg minus R equal to ma, and mg minus 0 equal to ma, and a equal to g. When R is not 0, A is smaller than G, or 10 meters per second squared. So this is part C. Two, given that the mass of the student is 40 kg and the acceleration is 8.17 so many meters per second squared, calculate the magnitude of the forces you have joined in part A. So this is too simple. So the weight W equals to mg, which is 40 times 10, which is 400 newtons, and we have 400 minus r equals to 48 8.17. So therefore the reaction R is 40 minus blah 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 40 minus that, and that is so using my calculator is 400 minus 40 times 8.17, which is 73.2 newtons.